Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun, and in today's video, we'll be looking at hierarchical cluster analysis. I will be using a tool which is called as STATCRAFT to demonstrate how hierarchical cluster analysis works. But even before I demonstrate how hierarchical cluster analysis works, may I request all of you to like, share, subscribe, and press the bell icon. As you can see in front of your screen, I have the power utilization data for all the regions in India. There are 33 different regions. Some of them are states, others are union territories. And we have the power consumption for 12 months in a year. You can see here, the first column is state. We have some of the important states in India like Punjab, Haryana, Rajasthan, Delhi, UP, so on and so forth. The second variable is April. Third variable is August, December, February, Jan, July, so on and so forth. We have data for 12 months in a year. We also have one interesting column, which is the total power consumed by each of the states. So using this data, what we want to do is we want to segment all those states and union territories where there is high power consumption. Similarly, we want to compare with those states where you have low power consumption. So to do this, there is a very interesting statistical technique which is called as hierarchical cluster analysis. Hierarchical cluster analysis is very useful when the sample size is small. How small? It is most useful when the sample size is less than 100. In this data, the sample size is 33. You can see here, there are 33 regions. So we have 33 records and we want to segment them into high power consuming areas, low power consuming areas, and moderate power consuming areas. In STATCRAFT, how do we perform hierarchical cluster analysis? To do this, what I will choose is, firstly, analyze menu. At the top left-hand side corner, you have what is called as the analyze menu. Let me click on analyze menu. Once I click on analyze menu, STATCRAFT displays all the different features that are present in STATCRAFT. As you can see here, since the technique that I want to use is clustering, I will choose the option clustering. Let me click on the drop-down menu. Once I click on the drop-down menu, STATCRAFT displays two options. First is k-means, second one is hierarchical cluster analysis. I will choose the second option, namely hierarchical cluster analysis. The moment I choose the hierarchical cluster analysis, you can see here a new dialog box, which is called as the hierarchical cluster analysis dialog box opens up. In the canvas on the left-hand side, what STATCRAFT does is it displays all the variables in the data set. In the canvas on the right-hand side, STATCRAFT expects me to give the variables based on which I will be segmenting the different regions in India. I will choose the different months here. So April, August, December, February, Jan, July, June, March, May, November, October, September, and I will ignore the variable total. So based on the average power utilization for these 12 months, I would like to segment the states. STATCRAFT is asking me how many clusters do you want to make? Now, this is a subjective decision because you can make 3 clusters or 4 clusters or 5 clusters depending upon the business need. In this case, I will choose 3 because I want to make a 3 cluster solution. You also see a very interesting option which says display diagram. If you choose display dendrogram, my apologies. Here it is asking me, do you want to display dendrogram? I will choose the option yes, because I want to display a dendrogram. A dendrogram is simply a graphical summary of the cluster solution. Once I have supplied all the variables, entered the number of clusters, selected dendrogram, I will move on to the options tab. There are a couple of interesting things here. When we segment the different states, we have to specify a distance method. Based on the distance measure, the states will be segmented. The default method is Euclidean, but we can experiment with different methods like maximum, Manhattan, Canberra, binary, Minkowski method. So just as we have different options for distance method, we also have different methods for linkage method. The default option is Watt's method, but we could choose any of the other method like Watt D2, average, centroid, or complete method. I will go with the default settings of Watt's method and Euclidean distance. The next option here is save. I can choose the cluster membership. What this does is, against each record, it will flag which segment does a state belong to. I can choose cluster membership and then simply click on OK. STATCRAFT takes a couple of moments to execute the hierarchical cluster analysis. As you can see here, this is the output window. At the back end, our code is running to execute the hierarchical cluster analysis. And you can see here, it has tried to create a data frame, and this is the distance matrix that it is creating. The reason as to why we provide the R code is because anybody can pull out this code, and if you want to try the same thing, or if you want to experiment with different methods, you can copy paste the same code in RStudio and run the analysis. What I'm interested in is what is called as the cluster distribution table. Now, this is very, very important because this tells me the number of states that are present in each group. You can see here group 1, group 2, and group 3. In group 1, there are 8 regions. I repeat, in the first group, we have 8 regions. I don't know which regions are there in this particular group. We have to investigate it. But my first impression is in cluster 1, we have 8 regions. In cluster 2, 21 regions are there. And in the last cluster, namely cluster 3, we have 4 regions. Let me scroll down. This is very, very interesting. What you see here is the cluster means. You can see here along the row, you have the 3 clusters and their profile. And in the columns, you have the monthly power utilization. We will look at this particular table, but even before interpreting the cluster means table, I would like to show you the dendrogram. So this is what we call as a dendrogram. Now, as I already mentioned, what is a dendrogram? It is simply a graphical measure of the cluster solution. In the vertical axis, what you see is the distance between the clusters when they are joined. And in the horizontal axis, you see the record number. You can see here, record number 19, 4, 22, 10. All these have similar properties, and therefore they all have been put in one segment. You can see here, there's a red color box. This red color box contains all these states. Now we have to go back to the data and see what exactly is record number 19, 4, 22, so on and so forth. Then you have the next segment where you have record number 13, 25, and 11. So this is group 2. Because these states are similar in terms of power utilization, they have been put in the second segment. Finally, you have the last segment wherein state number 25, 1, 2, 16, 17, 18, 3, and 12 have been put together. We will investigate the output further, but as of now, you can clearly see here, these are the 3 segments that we have been able to make. One important question here is, what is the profile of each of these three segments? It's very easy for me to say these are the three segments, but what is the profile of each of these segments? To understand the profile, we can look at the cluster means. Excuse me. Let's look at the April month. Look at cluster number 1. What is the power consumption in the month of April? It is 183 units. In cluster 2, it is very low. It is 29 units. This is the average units of power consumption. Look at cluster number 3. The utilization is very high, which is 350. When you compare cluster 3 with cluster 1 and 2, you can go ahead and confidently say cluster 3 has all those states wherein the power utilization is the maximum. In cluster number 2, you can clearly see the number is very, very small, only 29 units, indicating that in cluster number 2, the states are consuming very low power. In cluster number 1, what you see is moderate power utilization. Cluster number 3 is high, and this trend replicates for all the 12 months. May it be August, December, February, Jan, so on and so forth. Cluster 3, you can see here consistently, the mean value is very, very high as compared to cluster number 1 and cluster number 2. Therefore, we can say that cluster number 3 represents those states wherein there is high power consumption. Now, what about cluster number 2? Cluster number 2 represents those states wherein there is low power consumption. Cluster number 1 represents those states wherein you have moderate power consumption. So very, very interesting. What we have been able to do with clustering is to segment the states into 3 buckets. First cluster represents the 8 regions wherein there is moderate power consumption. Second cluster represents 21 regions wherein there is low power consumption. And finally, cluster number 3 represents all those regions wherein there is high power consumption. Now, one question that you might want to ask is, where are the states? Which are the states which are going into cluster number 1? Which are the states which are going into cluster number 2? And which are the states which are going into cluster number 3? To answer this question, what I'll do is I'll click on the view button. You can see here there are different options. I'll go back to the data editor window. What STATCRAFT has done is it has created a new column wherein you can see here it has displayed the column heading as H cluster. Now, what is this H cluster? H cluster is the output of hierarchical cluster analysis. It indicates the group membership. For example, the first 3 rows belong to cluster 1. The 4th row belongs to cluster number 2. I repeat, the first 3 rows belong to cluster number 1. Remember from the earlier discussion, cluster number 1 is the segment which represents moderate power consumption. Cluster number 2 represents low power consumption. Cluster number 3 represents high power consumption. Now, I may want to see only those states wherein there is high power consumption. Which are those 4 regions wherein there is high power consumption? This is where you can click on this option of filter. You can see here there's a funnel-like icon. This is the filter option. Let me click on the option filter. Excuse me. I would like to display only those states wherein there is a high power consumption. So I'll be choosing the filter for high power consumption. I'll choose OK here. You can see here only 4 states are displayed. If I scroll to the extreme right, the cluster membership is 3 here. 3 represents high power consuming states. Which are these regions? Uttar Pradesh, not surprising, Gujarat, Maharashtra, and Tamil Nadu. These are the 4 states wherein you see high power consumption. Now, you might want to apply a filter again to check which are those states wherein there is low power consumption. Let me click on this filter again. And instead of choosing high this time, I will apply the filter for low. You can see here, this is the condition. Hierarchical cluster is equal to 2. You can see here, these are all those states wherein there is low power consumption. You can look at the last column here, H cluster equals 2. H cluster equals 2 represents low power consumption. These are the 21 regions in India where you have low power consumption. Delhi, Uttarakhand, Himachal Pradesh, Jammu Kashmir, Chandigarh, Chhattisgarh, Goa, Dadar and Nagar Haveli, Kerala, so on and so forth. All these are those regions wherein there is low power consumption. And finally, if you want to check which are those states wherein we have moderate power consumption, I can apply the filter once again and choose the filter for moderate. H cluster equals 1. This is the filter. So let me go ahead and click on OK. What you see here is 8 regions wherein there is moderate power consumption. Let me scroll to the extreme right. You can see here the group membership is 1. So which are these 8 states? You have Punjab, Haryana, Rajasthan, Madhya Pradesh, Andhra Pradesh, Telangana, Karnataka, and West Bengal. In these 8 states, we see moderate power consumption. So this is the benefit of doing hierarchical cluster analysis. With the help of hierarchical cluster analysis, we have been able to segment the states into 3 groups. Now, you can do one additional level of check through a box plot. How do we show the cluster results through a box plot? Even before I construct the box plot, I will remove the filter and display the entire data set. Now, when I scroll to the right side, you can see here H cluster displays all the 3 segments. I'm interested in the last 2 variables, that is the total power consumption and their distribution for the 3 segments. The best visual summary would be the box plot. So to construct the box plot, I will go to Analyze menu. Let me scroll down. Once I scroll down, you can see the option for graphics. Let me click on the option graphics. You can see here, STATCRAFT displays different options that are available for graphs. Now, the graph that I am interested in is what is called as the box plot. You can see here the 3rd option from the top. First is scatter plot, second is bar plot, and the 3rd option is box plot. Let me click on the box plot. Once I click on the box plot, what happens is a new dialog box, which is called as the box plot dialog box, appears. Here, instead of multiple, I will choose a grouped box plot. There are 2 variables that I need to supply, one under the variables list and the second under the factor list. What I will do here is I will select the variable total power consumption as the variable. And when it comes to factor, I will choose the group membership. That is the 3 groups which represents different states. So total power consumption will be the variable that will be broken down into 3 different segments for hierarchical cluster analysis. Once you have selected the variables, very simple, please click on OK. In the output window, what STATCRAFT does is it gives you the output of the box plot. You can see here, this is the output of the box plot. Cluster number 1. Cluster number 1, the average power consumption is just less than 200. This is the cluster which represents those states wherein there is moderate power consumption. Very interestingly, look at cluster number 2. Cluster number 2 represents those states wherein there is the lowest power consumption. It is in single digit number. When I scroll up, you see cluster number 3, wherein there is the highest power consumption. So this is the segment where you see the highest power consumption. It has exceeded 300 units. So this is how you can construct a hierarchical cluster analysis based on Euclidean distance measure and check which all states have high power consumption and which all states have low power consumption. Further, you can do a box plot to check the distribution of power consumption across the 3 states. With this, I have come to the end of today's video. If you have liked this particular video, I request you to hit the like button and subscribe to my channel. Thank you very much for watching this video. Have a great day.